binary division. This is probably the most trickiest sort of concept to grasp in terms of how you actually do it, because it involves taking away numbers, so take away binary numbers, and it also is about remembering like where ones are placed and stuff like that. So it is a little bit tricky. However, I am going to try and go through it as best as possible, and if you've got any issues, just let me know, because I'd rather go over it and again and again and again until we finally get it. So 162. Now 162 is divisible by the number 6. Now, obviously we know that 162 divided by 6, I say we know, I've done this previously, is 27. So the answer we're looking for is 27. So what we're going to do is 162 divided by 6, which as you know should be 27. Now, when we do this in bus stop method, you have 1, 6, 2, and you divide by 6. Now, how many 6s are going to 1? Well, we know that 0, 6 is going to 1. And we know that we put that over there, so it's 16. So how many 6s are going to 16? Well, we know that 2 do, and that 4 remain. And then obviously in 62, 7 going to that. So that's how you work out how to divide numbers, right? Now, when you're doing binary, that's going to be a little bit more tricky because you can't actually do that, really. You can't do it because you're not going to be able to figure out what your remainder is just by simply looking at it. So let's do 16 divided by 162 again. So we know that no 6 is going to that, and we've got 16. And we know that at least 2 can go into 16. However, if we didn't know what his remainder was, how would we work it out? Well, how you work it out is you times this number up here by that number, so this by this one, and that will give you 12. And you're minus 12 off 16. And 16 minus 12 is obviously 4, so that's your remainder. So we know that this now is 42, which again obviously is 7. Now you have to do this in binary. If you don't do this, you are never going to figure out what that remainder is. You cannot figure out what that remainder is if you do not do this method of timesing this number by this number and then taking it off this one. So obviously taking 12 off of 16. So what we're now going to do is change this into binary. So 162 divided by 6. So 162 in binary is 1, 0, 1, 0, 1, 0, 0, 0, 1, 1. So that's 162. And we know that 6 is 0, 1, 1, 0. So that's obviously 4, that's obviously 2, that's 1, that's 8. So we know that this does equal 6. So when we're doing the bus stop method, so we know that 110 is 6. So we got to now work through it logically. So how many 110s are there in 1? Well, we know that there's definitely no 110s in 1 because that's too big. And then we're left with 10. How many 110s in 10? Well, again, there's not enough. So there's only 10, so that's nothing. And then that becomes 101. How many 110s in 101? Well, it's 101. We know that 110 is bigger because that's 6 and that's technically 5. So again, it's 0. And then this becomes 1010. Now, how many 110s can go in 1010? This is the question. Now, because it's only a binary system, whenever you divide into something, it can only be 1. It's either 1 or 0 because it's binary. So we know that it can at least go in it once. So now we need to times this number, so 1 by this number, 110. So we've got 1010, which is obviously this from up here, put down there. So 1010, including this 0. 1010 minus 110. We've got to do this to figure out what our remainder is. So we start with 0 plus minus 0 is nothing. 1 minus 1 is fine. That's just 0. And now we've got to this point where we have 1 into 0. But we have got a 1 here we can use. So we make that as 0. That becomes 10. So that'll become 1. and that becomes 0. So now this is a remainder, 100. So after we've done this 0 here, we can now have a remainder of 100 on that one. So we've now got a remainder of 100. And I'm going to delete this underneath, otherwise I'm not going to have enough space to work with. So we now have 100. How many 110s go into... Sorry, 1,000, because technically this 0 is here with that 100. So how many 110s go into 1,000? Well, we know at least one will. So now, 1,000 from here. So the 0 comes down, and then the 100 up here goes 0, 0, then 1. So that's 1,000. Minus 1, 1, 0. So what's the remainder? So 0 minus 0 is nothing. 0 minus 0 minus 1. Now this is where it gets tricky because you can't do that. So we have to borrow a 1 from this 0 here. However, this has not got a 1 either to work from. So we need to borrow this 1. So this becomes 0, and that 1 disappears. That becomes 1, and this 0 disappears. And this becomes 1 here, so this 1 has something to take away from. So 10 minus 1 we know is 1, because obviously it's, 10 minus 1, it's basically 2 minus 1 is 1. And then we have a 1 here now, so we have this 1 minus this 1, which we know is 0. And we've got now, we've got nothing here and nothing here, so that's obviously 0. So you're just left with 10 to work with. So we know that the remainder for this bit is 10. So how many 110s go in 100? Well, we know that it's nothing because it can't be, because it's only 100, which means that again we've got a leftover of 100 there. And the cycle starts again. So let's do it again. So we've now got 1,001. So the 1 comes down here, 1, and this 100 comes down here. So the 0's there, 0's there, 1's there. So now I've got 1,001 minus 110. So 1 minus 0 is still 1, because obviously when you take these two off each other, 0 into 1 is not going to do anything, so that'll still be 1. Now I've got the same problem, 1 minus 0. So we need to take 1 off here and pass it down the line. So that becomes a 1, and this becomes a 10. So pass down, pass down. So 10 minus 1 is 1, and then again 1 minus 1, so these two become 0, and then obviously there's 0 here, and there's nothing here either, so that becomes 0. So you're left with 11, so that becomes 11. Oh, and I've just realised that's not 162, that number should be 0 right there. Now, luckily, because obviously we know that this number divides into it absolutely fine, so we're now left with 110 at the end. How many 110s go in 110? We know that 1 goes in 110. And obviously 1 there. So that's the final answer. So let's add these up. So we know that if we put the binary system back in place of 1, 2, 4, 8, 16, 32, 64, 128. So we've got nothing here, nothing here, nothing here. 1, 1, 0, 1, 1. 16 plus 8 is 24. 2 plus 1 is 23. And 3 plus 24 is 27, which is the correct answer. That is exactly what we wanted. So you just have to logically go down the list of how this works. So as you're dividing your number, so you're checking that 110 goes into 1 first, you need to carry the numbers down, and then when you get to, say, this one, where 1 will definitely go into it, you then bring it down. So 0, 1, 0, 1, because obviously there's 101, and then you minus off 1, 110, because you have to find out what the remainder is. And that's basically what you do as you work down the line. Now, there will be some numbers where you get a remainder at the end. So say instead we did have 111, like I mistakenly put earlier. So we did have 111. So you would have 1, 1, 1 minus 1, 1, 0. And as you can obviously already see, that's going to leave you with just a 1. So your remainder in this case would be 1 if it was 163. So if this was 163 instead of 162, then the remainder would be 1 if you divided it by 6. Obviously, if you converted that back into binary, because that's the remainder 1 in binary, it's not actually a remainder in denary. The remainder in denary would be 1 over 6, which is roughly about 0.2-ish, something like that. So that's how you do binary division. Again, if you've got any issues on how to do binary division, I'm open to suggestions on how you want me to do it, or if you want me to go over anything in a different manner, I can. But I want you to do some more questions on that, because again, I want you to revise and make sure that you understand how this fundamentally works, because if you don't, you are going to struggle with it. So please try and figure out a way that works best for you in terms of revising and stuff, and I'll obviously give you some stuff to do as well, but that's basically how you do binary division with 2 different numbers.